Hello all, my name is Farnaz Baksh, and I'm soon to be a University of Guyana graduate with a Bachelor of Science degree in the exciting field of computer science. Today, I will be presenting to you my final year research project titled Investigating the Use of an Affective Robot to Aid Students with Learned Helplessness. I began this research with a curiosity of asking the question, is it possible for an artificial intelligent machine to recognize human emotions, my emotions as a student? I discovered the problem is twofold. On one hand, we have this study of getting machines to understand us, our emotions. This field of study is termed affective computing. And on the other, we found that student emotional experience impact their ability to learn. Academic struggles may lead students to the feeling of learned helplessness, especially when it comes to the motivational deficits. The field of learned helplessness was chosen as it closely relates to a student's mental ability to focus on studies during difficult times. And it was found as a prevalent educational problem right here in Guyana. Ideally, artificial intelligence applications, such as affective robotics, will be present in classrooms aiding teachers and students in the near future. The idea is to use the emergent technology of affective robotics to aid a student in overcoming their academic struggle and to influence a positive behavioral change. For my research, I wanted to know, how might students interact with an affective robot? How might an affective robot help students cope with learned helplessness? Does an affective robot works? And how can I create and test the multimodal solution? Meaning, having a combination of two or more education emotional cues. Turns out, I can. Focusing on facial and speech as my only emotional cues to measure, I have successfully used and implemented the Google AI kits. These kits communicate with each other on a server. The server was built using a Raspberry Pi 3 and the Flask framework in Python. But how does this all work?
You look beautiful.
The camera from the AI Vision Kit looks for a face. The program identifies how many faces found, and then scans to see which emotion they are displaying. That data is then sent to the server. The server receives the values, in this case, the emotion is happy. This is then sent to Dialogflow, which uses natural language processing to understand and respond to our facial emotions.
I am so proud of you.
Dialogflow then sends this response back to the server, which then forward the response to the AI voice kit. The voice kit uses text-to-speech and speech-to-text software to understand and reply to us.
Good job studying. You are incredible. Keep it up. I am proud of you. Good job.
+1 for open source. Thank you, Google. Evaluation. I aimed at collecting both qualitative and quantitative data. However, this was before the COVID-19 pandemic. I had to modify my methodology. Nevertheless, both types of data was collected. Testing was now intended to be conducted at a distance via video call. The main test was making sure that the artifact can identify faces on a screen and detect speech on a call. Sadly, the major change for my research was my target population. Even though I got university students, I did not get students with learned helplessness since I could not have administered the student behavior checklist procedure. I reached out to 15 participants, 11 were available and tested, of whom only 10 answered my questionnaire. My student participants range from year 2 to year 4 at the University of Guyana. Apart from stable connection, we conducted all testing during daylight period and asked participants to be in good light condition and an environment where they can hear and respond clearly. All right, brace yourself. I will take you through some of my findings now. The first test I conducted was a demo test with each participant, where I tested for a positive emotion, example happy, and then a negative emotion, example sad. Since I asked participants to hold their expression for a few seconds, the Vision Kit recorded a few values, of which I calculated the average to obtain a mean score. As you can clearly see, our artifact was relatively accurate in these detections. The second test that was conducted, I asked participants two questions. Question 1A, what was your most challenging course this semester? And how do you feel about this course? A lot was said and the Vision Kit had a lot to process. It captured many facial values, which I took the average of each participant and mapped it to the word they used to describe their feelings. When I asked my student participants what feelings or emotion do they associate with learning and how do they feel about learning something new, there were a lot of mixed responses for this question, and the artifact had trouble recognizing most of these emotional cues. Participants were saying that they felt both enthusiasm and angry, or that or that learning is both stressful and fun. Mixed feelings, right? So the results are quite interesting. Let's explore our qualitative analysis. Our qualitative data came from the user experience questionnaire, which consists of 26 scale questions. Participants were asked to complete this questionnaire after they interacted with the artifact. This chart shows the overall mean value for each of the 26 scales from the UEQ. Some of these features that stands out are how enjoyable or how understandable the affective robot was. Was it supportive or was it or motivating? Let's investigate. We can see here that 9 participants felt that the affective robot was supportive, with 1 being obstructive on the extreme left and 7 being supportive on the extreme right. Unlikable or pleasing? 80% rate the highest score pleasing. Note that these scales fall under the scale of attractiveness, which I'll explain in a few. Motivating or demotivating, with 1 meaning motivating on the extreme left and 7 being demotivating on the extreme right. This falls under the scale of stimulation. As mentioned, each of these 26 scales was transformed, and the transformed data from each individual response was categorized into 6 scales, namely attractiveness, meaning the overall impression of our prototype; perspicuity, meaning how easy it is to become familiar with the product; efficiency, how easy it is to solve the task without unnecessary effort; dependability, the control of the interaction by users; stimulation, how exciting and motivating the product is; and novelty, how innovative and creative the product is. The UEQ results can further be categorized into the following. However, in my research, I focus more on attractiveness and hedonic qualities, since that give me more insight into the student behavior with the affective robot. The mean of these qualities were calculated. Overall, participants found the affective robot artifact to be quite engaging, friendly, motivating, innovative, a great form of support, and they loved the idea of having a robot to help you study. There were many limitations due to the pandemic and with the artifact itself. The environment in which testing was conducted was not ideal, since the artifact is physical. It was shown that human has a stronger emotional response to more human-like robot, or what we call tangible AI. Due to the pandemic, it was not possible for participants to interact with the prototype in its physical form. Due to time strain, the current stage of the artifact is what I label as level 1, meaning it has limited verbal response as well as identifying facial expressions, which is more of a robot rather than an AI, thus the inconsistency of the data and improvement is needed. So, where do we go from here? We need to implement other facial expressions and verbal responses to our current artifact. Better environment for testing, maybe with the initial target population. However, this does require planning ahead. In the future, testing in a classroom setting with many students at a time to detect multiple emotional cues can also be considered. And lastly, explore other technologies to make a more advanced, effective robot. The ultimate question: did we achieve our objectives? Do we know how students feel about the effective robot while studying or as a companion? Yes, we do. We did build a multi-model solution. However, there are room for improvement when it comes to the accuracy and efficiency. And given the limitation, it was only one session. We could not have concluded that there was a positive behavioral change, which is supposed to lead to better academic performance. However, participants did say that it was motivating. So overall, did I answer my question? Is it possible for an artificial intelligent machine to recognize human emotions, my emotions as a student? Yes and no. We still have a very long way to go. Thank you.